Hello everyone, I would like to welcome you to this video titled Representing Algebraic Relationships in Tables and Graphs. And you will need to get out your Go Math book and turn to page 351 and also get out your pencil. And the goal for the video is for you to understand how you can use verbal descriptions, tables, and graphs to represent algebraic relationships. So let's take a look at the problem on page 351. It's saying representing algebraic relationships. So it's saying that Angie's walking speed is 5 kilometers per hour and May's is 4 kilometers per hour. So it show the distance each girl walks is related to time. All right, so what we have here is a table. We've looked at tables throughout this module. So we can see for each girl, make a table comparing time and distance. So this is a really good way to figure out how far, for example, Angie walks in 4 hours and how far May walks in 3 and 4 hours as well. All right, so it is important to understand that we know for every hour Angie walks, she travels 5 kilometers. Okay, so for this type of problem, we can see 0 hours, 0 distance, obviously. 1 hour, 5 miles, 2 hours, 10 miles, 3 hours, we can see, looks like it's going to be 15. 4 hours would be 20 miles. How do we know that? For every hour, it's 5 miles. Okay, so what's happening to X, for example, or the time? It's being multiplied by 5 in order to get it to the distance. So May, 1 hour, 4 miles, 2 hours, 8 miles. So we can see what's happening to our 1 in order to get it to 4. Adding 3, yes, but that does not work for the 2 and the 8. So we're multiplying by 4. So you multiply each hour by 4, and that shows you how far she travels for hours, for 3 hours, and also for 4 hours. Now what we can do is we move down another step to this. So we're representing algebraic relationships in tables. So this is the table. This is the graph now. All right, so it says for each girl, make a graph showing her distance y as it depends on the time. So again, this is the x-axis for time. This is the independent variable. The distance is the dependent variable. So as the time increases, the distance increases as well. All right, so for Angie, we would say we even have the ordered pair of 0, 0. So we just put that right at the origin there. And then 1 hour is 5. So we can see, first of all, this is 2, 4, 6, 8, 10. So intervals of 2. So 1 hour is going to be 5 miles. 2 hours will be 10 miles here. 3 hours will be 15 miles. 4 hours will be 20 miles there. Okay, and then as you plot your points, what you want to do is just connect these dots and just make that line going all the way through the graph there. And you know you've plotted your points the correct way because you're going to have a nice straight line representing this situation. So when we think about Angie's equation, we know that Angie, her distance is going to be y, time is going to be x. So what we can see is y equals the time, which is x, times 5. So 5 times x. In other words, we multiply x by 5 and we get the y. All right. So let's take a look at May's equation. So May was 0, 0 at the beginning. So put that dot. I'm going to make this red to make it a little bit easier to see as we connect our dots. So we have 1 and 4. So 1 hour, 4 miles. 2 hours, 8 miles. So we're just plotting our points on the graph here to show the relationship. 3 hours, 12 miles. And 4 hours, 16 miles. All right, now from here, what we'll do, we'll start at 0 there. We'll just connect our dots as we go through. We'll just have it keep going, showing that, for example, at 5 hours, it would be 20 miles there. Okay, and continuing on as we go through our graph. So the equation that would represent this situation for May, we have y. Remember, we always start out with y is going to equal what's happening to x in order to get it to y, 4 times x. So there is a question at the bottom that's saying, how can you use the tables to determine which girl is walking faster? And how can you use the graph? So if you take a look at the table, you can see, basically you compare the distances after walking the same amount of time. So right away, 1 hour, 5 miles, 1 hour, 4 miles. So we can see easily that Angie is walking faster. Now, as far as how can you compare the tables, basically, if you look at the steepness of the lines here, okay, we can see that Angie's is a lot steeper than May's. And because Angie's is a lot steeper than May's, then you can see that Angie is walking faster. So that's a way that you can compare the tables and also the graphs. So the next thing we're going to take a look at is on page 352, and that is writing an equation from a graph. Now, it's important to understand that when you see these types of problems, it's a lot easier to take a look at your graph and then fill out your table, and then you'll be able to see the pattern within the table in order to write the equation. Okay, so the story problem that goes along with this is Charisse pays the entrance fee to visit a museum, then buy souvenirs at the gift shop. Then what's a better souvenir than that gigantic stick of sugar that you can get as a souvenir at a souvenir shop? The graph shows the relationship between the total amount she spends at the museum and the amount she spends at the gift shop. Write an equation to represent the relationship. So what I am going to do, I'm going to take a look at my graph first of all. Okay, so I can see 0 and 5. I can see 5 and 10 here. Okay, there's 5 and there's 10. I can also see 10, and for this one here, I can see that it's 15. Okay, because it's lined up right with 15 there. All right, so I'll put 15 here. My next one, I see 15. All right, which is right here, and I can see right away that it's lined up with 20. So I'll fill that one in there. Okay, so you can see getting the data from the table, and then, I'm sorry, from the graph and putting it right in your table. Now the next one, I have 20. All right, and then from this one, you can see it's going to be 25. It's right in line with the 25 there. Okay, so you can see this represents the x-axis, this represents the y-axis. Therefore, this is going to be the dependent variable. This is going to be the independent variable. Okay, so taking a look at this pattern, what is the pattern in the table? All right, so what we can see is that the total amount is 5 more than the gift shop amount. Okay, so gift shop amount 0, total amount 5. Gift shop amount 5, total amount 10. 10 and 15, 15, 20, 20 and 25. So we can see the total amount is 5 more than the gift shop amount. And I would like you to fill the table in just like I did, and also fill in letter B like I did as well. Now it's saying write an equation that expresses the total amount spent, Y, in terms of the amount spent at the gift shop, X. Okay, so again, with these equations, you always want to start out with Y equals, and then what's happening to X, okay, the X axis, in order to get it to Y. Okay, we can see that Y equals X plus 5. Okay, does that make sense? X plus 5, for example, X, 0, plus 5 is 5. X5 plus 5 is 10. X, which is 10, plus 5 equals Y, 15. So that does make sense, and that does follow that pattern there for letter C. So again, if you're taking a look at this problem, look at the graph, and that will help you fill out your table, which will eventually help you create an equation that represents that situation. So now what we're doing is just graphing an equation. All right. And let's take a look at page 354, and we're going to look at number 4. Now I filled in 0, 1, 2, 3. So what we do is we have the equation x plus 2.5 equals y. Now that may seem very confusing. However, we have our x right here. Okay, so what we'll do, and we're going to make an ordered pair from this. So x for this one is going to be 0 plus 2.5 equals y, which would be 2.5. You want to write it here instead of down there. 0 plus 2.5 equals 2.5. Okay, so x, my ordered pair, is going to be 0, 2.5. Next one, let's say x is 1. Pretty simple, just plug in 1 for x, add 2.5 for it. That's going to give us 3.5. So the ordered pair, x would be 1. How do we know that? Because we see it right here. Ordered pair would be 1 and 3.5. Why 3.5? Because when we add x to 2.5, that gives us y, which is 3.5. So we'll do the next one. 2 plus 2.5, following this equation, is going to give us 4.5. So we have x is 2, y is 4.5. Next one, plugging in 3 for this equation. We have 3 plus 2.5 is going to equal 5.5. So x will be 3, y would be 5.5. Okay, so that's completing this equation. Now we have our ordered pairs. Now what we will do is we will graph them. Okay, so for this one, we have 0 on the x-axis and going up 2.5. So I'll put my point right there. Next one, we have 1 and 3.5. So we go over 1 and we go up 3.5. Next one, we have 2 and then 4.5. And then 3 and then 5.5. So go over 3 and go up 5.5 between the 5 and the 6. We have our point right there. And then what we'll do is we'll just connect these dots and we'll keep a straight line. Just do the best you can. If you have a ruler, that's great. And we'll make that straight line representing this algebraic equation all the way through our graph there. So this concludes the video on representing algebraic relationships in tables and graphs. If you have any questions about this concept, please come and see me.